morning, Adam Symerewicz. Thank you, Bartosz, for those kind words. Well, yes, I have quite a challenge ahead of me to try to tell you, in an interesting way about data integration. Unfortunately, there won't be any genius here, so I don't have any buzzword to pique your interest differently. I hope that what I've prepared will be enough. There should be somewhere here. Okay. This is what our agenda will look like. First, we will talk about when we should, or rather must, integrate this data. A big point. What questions should we ask ourselves before this integration? And there are really a lot of these questions. We once prepared something like a questionnaire. I don't know if there weren't about 100 questions there. So there are quite a few. And all of them have some significance on how the architecture will ultimately look. What approaches do we have to architecture and tools? Then we'll try to compare the available integration tools, also looking at certain dependencies that immediately point us to certain tools that we have available. Later, we'll wrap it up somehow, and if things go well, and we have some time, there might be a Q&A session. All right. Here we have the architecture diagram. You'll probably see it a few times over the course of these 2 days. In any case, the purpose of showing it in my presentation is to illustrate exactly what I'm talking about. So I'm talking about a part of this entire journey, this architecture. We all know that it's not the goal that matters, right? But the journey itself. My colleagues will probably try to prove otherwise later. So we'll talk about this integration, about ETL, ELT, processes, and so on. All right. This is something that should already give you some insight. Certainly, at least the first of these points is something you've encountered. It's known that we need to integrate data when we require something like central reporting. Probably each of us has worked in a company or dealt with exporting Excel files from various systems that were distributed, then piecing it all together. Everyone has a different Excel. Everyone has different KPIs calculated differently. And then nothing matches during the management meeting, and you have to quickly color it green before the meeting. So now in these times, with all the available tools and the knowledge we have, we don't have to accept having this distributed reporting, and we shouldn't even agree to it. We shouldn't tolerate it, because it is now very easy to implement. So this is the first and most important point, which often leads people, our clients, towards the integration of this data into a warehouse, for example. We have another point which is more straightforward, as it involves the emergence of new sources. This means it assumes that we already have a warehouse, but new sources have appeared, and we need to integrate them. So we no longer need to take that initial big step. As one of our analysts recently said, we were on the edge of a cliff, but we took a step forward, and we need to integrate this data when our architecture has changed, when we are doing some migration. Sławek also talked a bit about this. What questions should we ask ourselves? And now, my dear friends, I would like to encourage you to legally use your phones at this conference. Why are we doing this? Well, great. That's my favorite question, actually. I always ask myself this. And the answer is always that we do it because we enjoy it. What are our data sources? This is very good. It's a very good question. Absolutely necessary. What is the goal? I don't know if we can turn this off. But I see something about Excel, so maybe we don't want to reveal that. Good morning, good morning. Will they fit in Excel? Let's hope they fit, yes, in Excel. All right. Sorry, because I switched to Menti here, and we'll return to my presentation. if possible. All right. So looking at these questions, you really hit the mark with some of them. I believe that these questions can be divided into areas where we should be asking ourselves these questions. These are the strategic, technical, architectural tool and operational cost areas, which is probably our favorite. And indeed, in the strategic area, the question would be included, why are we doing this? Why? Why do we want to integrate this data? We somewhat answered this at the very start, that usually it's the need for central reporting, and in general, reporting that is stable and trustworthy. We have one such source of truth thanks to integrating it. What business decisions will be made based on this data? It was also paraphrased there about what we ultimately want to achieve. One of those strategic questions, Dombasana, which often causes a lot of controversy, is whether we need this data in real time or if batch processing is sufficient. And here is another question for you. For example, do we need the data every 5 minutes? For you, is that batch or real time? Who thinks it's real time? Please raise your hand. Well, I think differently. I believe that every 5 minutes is batch, not real time. Sławek talked a bit about real time. Indeed, it comes with a few seconds of delay. And this results from the capabilities of the tools we use for this, not necessarily from our needs. Let's move on to the technical questions. Here, we really need to ask ourselves what sources we have and where the data should flow from and to. So in a way, that question was also asked in Menti. Do our data require transformation? Do they need cleaning, some kind of enrichment? What is their structure? Is it SQL? Are they unstructured data? Or maybe we have some Excel files, for example, that are created manually and need to remain that way. But we want to integrate them into our data warehouse because they enrich other data in the reporting context. And an important question is, what is the volume of this data? Because we will transfer petabytes of data differently than we will transfer gigabytes of data. We can use much lighter and much cheaper tools, which I will also talk about later. Architectural. There is one such question. The next question, let's say controversial. Do we have any preferences regarding a particular cloud? Here, some discussions about these cloud preferences are sometimes abstract. We work with GemUp with every cloud when it comes to hyperscalers. So for us, it doesn't matter that much. But there are cases, as Sławek mentioned a bit, where we use marketing data. And in those instances, for example, Google is much more advanced and the data is much more granular. So it makes sense to use something like BigQuery for that. A very important question, in my opinion, both architecturally and tool-wise, is what competencies do we have in the team? It often happens that on paper, the best solution would be to write some flexible code. But perhaps we have such competencies in the team that the best solution would be a more expensive tool, which is low code or no code, where the interface is clicked through, but we can maintain it ourselves. And there's also the question of how this integration will fit into the entire architecture. If we already have a data warehouse or some tools in the cloud, then perhaps instead of creating everything anew, as if we're making a revolution, we might need to utilize what we have, as Sławek also mentioned, and build upon it, because when it comes to these tools, there really isn't such a huge difference between them. So we need to make a sort of profit and loss assessment, so to speak. Operational questions, of course, include what budget we have, what the implementation cost will be, what the maintenance cost will be, and whether we can even maintain it ourselves. Are there any hidden costs? For example, it might turn out that we need to spend a lot of time training the team to be able to maintain it at all, and so on. Here we have a slide with steps for data integration. I have proposed a certain flow here. How would we do this step by step? In fact, this slide, together with the next slides, are very closely connected. And there is a certain order to it. But really, whether we need to do all of this at once depends on how mature our organization is and how maturely we approach this. Because we have steps here like source identification, designing the architecture, and tool selection. So, in a way, we are already answering the questions we asked ourselves earlier. We have implementation and testing. Well, earlier, right at the beginning. We have the definition of the goal. But as you will see on the next slide, we have something like ensuring data security and compliance. We very often need to think about this right from the start, even before we think about any tools, perhaps after defining the goal, but before the architecture. The implementation of monitoring and alerting should, of course, also be done somewhere, Shai, during this development. It would also be good to plan scaling somewhere earlier. And of course, at the very end, there should be documentation of the process, and the expansion of this knowledge within the team that should maintain it. What is our approach to this architecture? Here I will talk about two such approaches. There are a few more, and you can look at it from several dimensions. But here is something where we always ask ourselves whether we should use serverless or serverful. Here, precisely because we are focusing on the cloud, serverless is very dominant, more dominant than serverful. There could also be some local servers placed there if it were not to be the cloud, some servers set up on the cloud. For example, if something like this already exists, because that's how these integrations had to be implemented in the past. As you can see, we have tools here. These are actually 4 groups of tools. I will show this shortly in a comparison. And we have equivalents from all 3 hyperscaler clouds. So we see that we have 2 tools where we need to manage the underlying infrastructure, and the rest of the tools are serverless, where we don't manage that. We only manage the logic of how it works, but not necessarily the compute underneath. And what is serverless good for example? First of all, if we want to do something relatively quickly, such as implementing a POC or MVP, it's very beneficial to use serverless because we don't have to spend time setting up the compute. Serverless is also good if our data traffic is irregular, because typically, with most of these tools, we pay for the actual usage of these tools, not for them just sitting there on the cloud and transmitting data once a day, while we pay for them 24/7. And if they integrate with many cloud services, then the serverless approach will also be better. Serverful can be thought of, for example, not just in the context of these 2 tools, but generally in the context of serverful. You can think about it if you already have some resources that you want to use. And obviously, you don't want to sell your servers now, for instance. And if we have a large team, if we already have a team that is capable of maintaining it, then we can also consider serverful in that case. And the second approach, some kind of bone of contention, let's say. This is the code or no-code approach, meaning some tool with a user interface, where we can practically click through these flows. Obviously, the things that are no-code are much simpler. They are very often useful for some POC, some demo, or some MVP. I don't know. Anyone who has ever used Azure? Data Factory knows that, for example, from such SQL, if we have access there, we can retrieve data statically. In one go, within an hour, depending on the volume. So for example, if we really want to quickly start the work of our analysts, we can use Azure Data Factory. Of course, it will be much more expensive in such regular flows. And it also has its own, just like other no-code tools, predefined connectors. So if we need some custom, non-standard approach, it will always be better to use these tools with code because we write the logic ourselves there. These code tools are also much easier when it comes to CI/CD automations, but I won't focus too much on that. No code, as I mentioned earlier, is much easier to maintain for less technical people. All right, let's move on to comparing the tools. I have generated a matrix here with the help of my best friend, and you can probably guess who that is by now. So here we have a group of these tools. These are the equivalents in these three hyperscaler clouds on AWS, Google Cloud, and Azure. As we can see, we have this ETL batch data processing here. Although I would even say that these are tools that are very well suited for streaming. We have these no-code or low-code tools such as Azure Data Factory, IGTOS, or Google Cloud Data Fusion. I think I won't be exaggerating when I say that this is our favorite group of tools, which are very lightweight serverless functions and serverless containers. We will use the former if we need very strong scaling. If we need to transmit data continuously and analyze it continuously in very short time windows, let's say. No-code tools, as I mentioned earlier, we will use if we want to maintain them ourselves and don't have much technical expertise, or if we want to do something quickly, we must be aware that they will simply be more expensive because that's always the case. When it comes to serverless functions, they are very delicate functions. If we had more time, I could elaborate on this because, as I mentioned, these are our favorite tools. Whenever we have some requirements, the first question I ask myself is whether I can do it with a cloud function. If the answer is no, then we start to think of other solutions. They are cheap, suitable for simple workflows, API flows, and small data volumes. But as it is written here, they are also event-driven. So if we have workflows that don't need to be continuous, don't need to be streaming, but must be triggered by an event, then these functions are also perfectly suited for that. If we have a more complex deployment, for example, we need to install additional drivers. Or if we have things that need to be installed, which cannot be handled by, for example, a Python package that we import, then it's good to use serverless containers. All right. So, in summary, we have a conclusion here. As you can see, data integration is not just about choosing a tool, but also an architectural decision. Here, what is most important to me, and what we focus on very strongly, is the approach to concentrate on needs rather than tools. It's often something like this that it's a bit difficult to approach it this way for people who are perfectionists and think about a specific tool without paying attention to the actual need. They just focus on that. But that's not a good practice. That's not how it should be done, for example. And you need to pay attention to those needs. And asking those good questions, as we've already seen, there are a lot of questions to be asked. This can definitely be done iteratively. But the more questions we ask ourselves, the more problems we save ourselves from in the long run. All right, are there any questions for me? This picture is a bit outdated. There should now be someone related to Gen AI, a prompter, a developer, and so on. But the situation for us data engineers remains unchanged. One little microphone hidden somewhere. Exactly. As you can see. It's that simple. Simple is harder than easy. That's the difference. But as you can see, it's not difficult. I mean, let's say with my experience, it's a very subjective assessment. For someone else, it might still remain easy because it's some action on the interface. While the rest might be difficult or extremely difficult, for example. All right. If anyone would like to talk to me about something other than Gen AI, for example, about data integration, you're welcome to do so. Of course, we can also talk about Gen AI, but I think in such a situation, it would be better if my other colleagues took care of you.
Thank you, Adesh. As we can see from the Menti results, we can't escape Excel even in the case of cloud integrations.